Hello, everyone. Welcome today to Banter with Bacteria. On our today's guest, we have Dr. Salentic. She has been my professor for my immunology class, and Dan, I did get to learn so much from that class. She has studied from Michigan State University, and she's a professor in Wright State University. And I'm so happy to have you here, Dr. Salentic.
Thank you. Glad to be here.
So today we're getting into knowing about what immunology is and why it is important to study that and just know more about Dr. Salentik's research work. So, Dr. Salentik, let's first start with what is immunology and why do you think it's important to study it?
In a nutshell, immunology is how our body protects us from foreign invaders, such as bacteria, viruses, anything that could disrupt our health and vitality. But on the dark side, immunology can also be responsible for allergies and autoimmune diseases. So it has both a beneficial, keeps us alive, but then also a potential to make us sick. And with the recent COVID epidemic, pandemic, we can see that immunology played a vital role there.
Of course.
Yeah.
I agree.
Yeah. Most diseases are based with some kind of immune problem, whether it's inflammation or it's an outright attack of the immune system against self.
Okay. Thank you so much for that. And how did you develop interest into immunology? Growing up, why did you know or want to study immunology?
Yeah, that came when I went to undergrad. So I went to Lake Superior State University for undergrad, which is in the Upper Peninsula of Michigan. It's beautiful up there. I'm going there this week.
Oh, that's nice.
Yeah, it's really pretty up there. But I went to Lake Superior State University and I took an immunology class, which really fascinated me. So that got me interested in immunology. And then I also took a toxicology class, which also got me really interested. Two different professors. And then I found out that you could marry both of them together. And I'm an immunotoxicologist. That's what I was trained in. So I was able to go to some local meetings when I was an intern at SC Johnson Wax. I was able to go to a regional chapter meeting for the Society of Toxicology and learn a lot more about immunotoxicology. And that's the rest of the story, or the beginning of the story. And then now I've been an immunotoxicologist for over 30 years, 35 years.
Wow, that is beautiful. I do agree that immunology classes do really change a lot of things. And since you've got this up, what would you say is toxicology and how is it different from what immunology would you study in immunology?
Well, with toxicology, it's a broader term, it's a broader field, and it looks at anything that can adversely affect the body or the environment or wildlife. So it doesn't have to just be human health. It could be any health of any living organism, and including plant matter. So it's looking at the effects, the adverse effects of chemicals. Most chemicals that you think of are not just industrial chemicals or pollutants. They include anything in a tomato, right? Everything has a chemical in it. Our body is made up of chemicals.
I know.
And so some chemicals are toxic and some chemicals are naturally formed and are more toxic than some man-made chemicals. So it depends on the dose makes the poison is one of the well-known characteristics. One of the most well-known mantras of toxicology is the dose makes the poison. But anyway, it's just any adverse effect that can happen. We study that, but then we also study what do we do about it. So that's the other side of toxicology. Okay, we identified an adverse effect. Now what do we do about it? Can we treat it? What's the best way to avoid that toxic effect? And sometimes when you find a toxic effect, you find out that it might be helpful in treating cancer, for example. So there's always a double-edged sword. It may be bad, but maybe you can use it for something good as well.
I agree. So, for someone who does not have any idea about what or toxicology is, how would you dividing this question into two parts? So, first of all, what would you say are the most important things someone must know, even like a normal person should know about immunology or the immune system, or just knowing about what your body does for you on an everyday basis, like so many cells involved. And the second part is a lot of people normalize taking medications, and what's your take on it, like being a toxicologist yourself? Is that normal, and how often would you advise them to do so, and to what extent is taking a pill okay?
That's a loaded question. First, for immunology, the basic is that it is our protective system. It includes our skin, which forms a physical barrier. It includes proteins that we secrete that hopefully break down bacterial walls so that they won't hurt us, or secrete other chemicals that can prevent the bacteria from entering into our body. And then we also have cells that are helpful at fighting the bacteria that does get inside our body. And so those could be cells that are very nonspecific. In other words, they can fight anything that gets into the body. And then we can also have specialized cells that fight only particular pathogens that enter the body. And so if we did not have a functioning immune system, we would not survive childhood. We would die. So it's essential to survival. And not only do humans depend on a functioning immune system, but animals do too. All the way from fish to cats, dogs, humans. All of us have some sort of immune system. It's just that some may have a less developed immune system, like a fish has a different type of immune system than we have.
Right.
Yeah, so it's essential for life, and it can also be a problem at times if we react to self and we develop an autoimmune disease, or if we have allergies. That can be a real problem. We usually can manage that okay with drugs, but then there are some people who have such severe allergies that they actually take parasites to try to decrease their allergy.
Damn. Okay.
Yeah, because with allergies, it's an IgE mediated response, and IgE is a type of antibody.
Right.
And the whole point of it is to expel the parasite. But in the developed world, we don't really have parasites. And so there isn't anything to keep that in line. And sometimes it gets a little out of whack, and we start developing an IgE response to pollen or dander or something like that, and then we have an allergy. But if you, and this used to be quack medicine, but it's showing that there is some efficacy. If you take a small amount of parasite, you put your antibody, your IgE, back in line. So it fights the parasite like it should, instead of going after the pollen and the dander, which is interesting. I'm not to the level of trying that yet, but I do know some people who swear by it.
I think you also just very cleanly mentioned allergies to people.
Well, good. In terms of drugs, it's always going to be risk-benefit ratio.
Can you talk a little bit more about it? Because I think people need to know it.
Yes. Nothing is without risk. Drinking water is not without risk. You could drink too much water and have some massive problems, even die if you drink too much water. So nothing is without risk. You just have to determine what risk you're willing to take. And with medication, the risk may far outweigh the benefit. In other words, you may not be able to perform as you normally would, or be able to hold down a job, or be able to feel comfortable and do everyday activities if the side effects are too huge from a drug. The reverse is maybe you won't live and maybe you really need the drug. So there's always some deep conversations that have to happen with your physician to know what is the risk, what is the benefit, and should I take this drug? Because there are some side effects that are really not fun to deal with. And But the benefit may outweigh those side effects. If it allows you to maintain a fairly normal lifestyle, and you just have to deal a little bit with some side effects, like there are some drugs that will cause shaking. Antidepressants will cause some shaking in your limbs, which could be a real problem depending on what you do. But then if you're in severe depressive state, you need to have the antidepressant. So there's always some kind of give and take there. There's nothing without some risk. I wouldn't be a pill pusher.
I agree.
But there's some real reasons to take drugs. I mean, the biggest thing is to make sure that your physician, if you have multiple physicians, that they all understand what you're taking.
Yeah. Thank you so much for that. I think we've really set a good ground in people understanding what immunology is and what toxicology is. Let's get a little bit more deeper into what do you study in your lab, and what any projects that you would want to mention that you're working on right now.
Yeah, in my lab, we look at how chemicals affect antibody production. And antibodies are part of the immune system that helps to provide protection against pathogens that are extracellular. And what I mean by that is they don't invade the cell. They're outside of the cell. And antibodies are really good at stopping a virus from invading a cell. But once the virus is inside the cell, an antibody can't do anything because it's a pretty big molecule, a pretty big protein. But it's really important in just stopping, if you've got the antibody around, stopping the virus from infecting the cell. And then it's also very important in our gut health, because we have a lot of bacteria in our gut that we're supposed to have, but we want to keep them in check and make sure that they don't overwhelm our gut. And that's a big area of pharmaceuticals and also dietary supplements, is all about supporting your gut microbiota. That's all over ads and things like that. And antibodies like IgA, which is just a different type of antibody. We already talked about IgE, which is our allergy antibody. But IgA is a really important antibody in the gut. And it helps to just maintain those normal levels of gut bacteria. So we've got a lot of different roles for these antibodies. We also have IgG antibodies, which are important for our overall health. IgG can go pretty much everywhere. It can cross over to the placenta and protect the infant. So it's an important antibody. And basically what they do is they just surveil and they target pathogens that shouldn't be there, and then other cells of the immune response clear those pathogens. But where my lab is interested is in how these antibodies are made. What regulates the production, and how do chemicals potentially alter the production of the antibodies? And do they target specific classes of antibodies? In other words, maybe we have more of a increase or a decrease of IgA antibodies, or an increase or decrease of IgE antibodies. If a chemical can induce more IgE antibodies, well, that could be a problem for allergies. But if we have a chemical that maybe decreases IgE, maybe that's a potential pharmaceutical target at some point. And it's a pretty complex regulation. It involves a lot of molecular biology and genetics, and looking at the gene and seeing if maybe some people are more susceptible to certain chemicals versus other people. And that's what we're looking at. We're doing a lot of gene editing, using CRISPR gene editing to try to make or simulate different genetic profiles of people, and then see if we can detect a difference in sensitivity to chemicals that could target antibody production. One of my grants is it's a TERP grant, which is a toxic exposures program. That's part of the military. So we're looking at some military relevant chemicals to see if they could alter antibody production, because if they decrease antibody production, for example, for the military, that puts the military personnel at risk of maybe getting sick more often. If they increase the antibody production, that could put them at risk for allergies, which if you have really severe allergies, it is hard to function.
It is.
Or what would be even worse is if they develop some kind of autoimmune disease. And when I say autoimmune diseases, that's a huge spectrum. That could be celiac disease, which is more of a hypersensitivity against gluten than an autoimmune disease, but it could include lupus. It could include arthritis. There's all kinds of autoimmune diseases out there.
That does sound very interesting. And I have two follow-up questions for you here. We spoke about IgA that is mostly present in the mucosal immunity and how it regulates the gut and gut microbiota. There's a lot of people out there who, even probably nutritionalists, that say taking immune shots, like say just ginger garlic shots and things like that, really changes or does something to your immune system. Do you think that's a truth or is it a myth?
I don't know. That's a really good question. I've also heard that with ginger, but I do eat a lot of ginger and garlic, but it's because I like it. I think that if you like it, go ahead and eat it. But I am not a huge proponent of doing shots because, well, for one, toxicology is the other side of pharmacology. And pharmacology is all about how do drugs work? How do they go throughout the body? The way that you take a drug could affect how it gets to different places. So mostly we ingest ginger and garlic through our food, and that is usually the normal way. So you have to think about the processing that occurs in the stomach and then in the gut. And if you just take an injection, that worries me a little bit. I would want to see some evidence that would support that before I would say, yes, go ahead and do that. And I'm not exactly sure what you mean by injection. If you mean just do an IM, intramuscular injection of ginger, that I'm pretty skeptical about because you're not going the normal way that we normally would take ginger, which is through our diet. And if you do, you also have to think about, and this is pharmacology principles, which mirror toxicology principles. You have to think about how the drug is absorbed, how is it distributed through the body. If it's lipophilic, then an intramuscular or an IM injection, it would pass through the body. But if it really likes to bind proteins, it would get sopped up right away with the proteins. I mean, eventually, hopefully, it would get to the blood, but it's hard to say. It really depends on what we call pharmacokinetics, which is your absorption, your metabolism, your excretion, your distribution. You really have to think about all of those things with drugs, and they're going to change depending on how you deliver the drug.
Okay. The second part for this question was, we do hear so much about vaccine controversies of late, especially after, like you said, COVID pandemic. I know we did study some papers about vaccines and its side effects, but what's your take on it? And before that, I think you spoke about how different drugs have to be taken different ways and how they affect the body differently. Do you maybe want to talk a little bit more about it in case?
Okay, yeah. So I'll talk first about drugs and how they affect the body if you take them differently. For example, there's some drugs that are topical. And so you would put them on your skin, and they would have to be somewhat lipophilic so they can get absorbed across your skin and then go to their site, of their target site. If you were giving a drug that needed to be metabolized into an active form, depending on what is required to metabolize it, you may not be able to put it on the skin because the skin has certain metabolic capabilities, but it's not as good as the liver, for example. The liver is our big metabolizer.
Mm-hmm.
So you have to think about all of those. Well, the drug companies have to think about all of those different
Mm-hmm.
mechanisms in order to figure out what's the best way to deliver the drug. And then also what is going to be the actual effective concentration. For example, for some drugs, they like to bind serum proteins.
Mm-hmm.
So once they're bound to a serum protein, they can't do whatever they were supposed to do. So you would have to adjust the concentration you gave to make sure that you gave enough of an effective therapeutic concentration.
Mm.
Now, that could be different in different people
Mm-hmm.
because your serum protein levels could change depending on your disease state. So if you have more serum protein, you need more drug. If you have less serum protein, then you want less drug because you could get into a toxic
Mm-hmm.
concentration. Then we also have other people who are high metabolizers and people who are low metabolizers. So if you're taking a drug that requires metabolism to become active, the high metabolizers will quickly get to an effective dose and concentration.
Mm-hmm.
It'll take them shorter time to get there. The low metabolizers will take them a longer time. And then you also have to think about, well, if the drug needs to be metabolized to be removed or eliminated from the body, if you have a slow metabolizer, you could get to a toxic concentration in that person
Mm-hmm.
and lead to all kinds of side effects that you have to think about compared to a high metabolizer.
Mm.
That there's a lot more to be said about all of that, but
Right.
there are a lot of different considerations, and often when we're doing testing of drugs, it's usually healthy males
Mm-hmm.
that are evaluated.
Mm-hmm.
Well, the drugs usually are going to be given to non-healthy people who are of either gender. And then what about children?
Mm.
So there are a lot of considerations that are left out if you just focus on a healthy male population. And then you also have to consider, well, what's the ethnic diversity that's involved in the testing, because there may be differences in terms of how different ethnic groups might metabolize, or maybe not only metabolize, but there could be differences in how the drug works in different groups.
True. Is there a reason why they pick only male candidates and healthy ones? Or is it just...
Well, they were trying to move away from that. I am not sure how well that is going, but they were definitely trying to move away from that. But
Yeah.
it's our phase 1 trials is to make sure it's safe.
Mm-hmm.
And usually they use volunteers, and they tend to be healthy male volunteers. But I think there was a push to try to recruit more diverse groups.
Mm-hmm.
Eventually, you do have to get into the population base that you're interested in to
Right.
make sure
Mm-hmm.
that it's going to be efficacious.
Mm-hmm.
But that's not exactly something I've been keeping up on. But there is a lot to do with the clinical evaluation of a drug and whether or not it's going to be efficacious, meaning that it's going to be effective and safe.
Definitely, yeah. I'm sure there's a lot more that goes into it than just like a 5-minute, okay, this is what's happening.
Yeah, and there's been a recognition of that for sure from a gender. I think where we're probably lagging behind a bit is with pediatric medicines. But that's a tough one. I mean, who wants to volunteer your child to try out a test drug? Yeah, that's not as easy.
Yes, so talking about efficacy, let's get into vaccine efficacy and COVID in particular, if you want to deep dive into that.
Yeah, so I would say most healthcare providers and public health professionals would agree that the development of vaccines was a game changer in increasing the lifespan of humans. Vaccines they allow us to essentially pretend that we're being infected by the pathogen when we're not, so that we can build up immunity. against the pathogen without first getting sick and potentially dying, and then surviving and building up the immunity. So they take care of that first route.
That's because body has memory, which
Memory.
becomes, yes,
Yes.
very important, yes.
Yeah, and that only will happen with what we call adaptive immunity. So when I did my very quick overview of immunology, we have cells that will just protect us against anything and everything. They don't really care what it is. They're just around to offer protection, but they maintain the certain level of protection. Once the infection goes past their ability to try to stop the infection, we bring in what we call adaptive immune cells, like B cells and T cells. And B cells are the ones that make antibody. And T cells, they do all kinds of things. They can directly kill cells, or they can help B cells make antibody. And both those cell types are very specific to the pathogen that we're trying to deal with. So if you're trying to protect yourself from COVID, for example, and you take the COVID vaccine, you're taking a piece of the virus, a non-infectious piece. So you cannot get COVID from the COVID vaccine.
Right.
Not from the vaccine. That doesn't mean you can't get COVID. If you're around somebody who has COVID, you could still get COVID, right?
Very important thing for people to know.
Yeah, you're not going to get COVID from the vaccine. And what the vaccine does is it wakes up the immune response and says, hey, there's this foreign particle that you need to respond to. And that foreign particle happens to be part of the COVID virus. And so that way, when you do get infected with COVID, your body's like, oh, I've seen this before.
Right.
And they're quicker. Your body's quicker at responding to the virus because it's already been woken up. It's on its guard. It's ready to fight it. And so doesn't mean you are not going to get sick. Doesn't mean you're not going to get infected. You will. But you should mount a pretty fast and effective immune response and not be sick as long and not have the long-lasting, long hauler effects that people have been seeing when they've gotten infected with COVID prior to developing this immunity. So yes, you can develop your memory by getting infected and surviving, or you can develop a memory by getting the vaccine and not getting infected. I would prefer to develop my memory from a vaccine than actually getting infected, because we do know that there are many, many long-term effects that have come from having the virus, having COVID. There, again, and I'm going to circle back again to nothing is 100% safe.
True.
Yes, there are some side effects with vaccines. I would say that the risk benefit is really, really positive for having the vaccine, because the side effects of having COVID from the data outweigh the side effects of having the vaccine. And if you also look at how these side effects of the vaccine are reported, it's usually an association. In other words, you got the vaccine and then you had some kind of side effect that you report that happened around the same time. It's not a causation. We don't know for sure that it came from the vaccine. I'm not trying to discredit it as a possible side effect. It's just that it's really hard to say for sure that everything that gets reported as a side effect due to taking the vaccine is really due to taking the vaccine.
Right. I read this theory which is called the iceberg theory, which is like the tip of the iceberg is only the side effects. Like it's a subset of a subset, the side effects of a vaccine. Well, the bottom of the iceberg is the actual side effects if you're affected by the disease itself. So yeah, it's a lot more better to have the vaccine and have its side effects than not take the vaccine at all.
Yeah, and that's not to discount that there are probably some vaccines that have some directly linked side effects to them. but again, from a human health perspective, the risks are so much lower than actually having the disease. The measles outbreak is a good example. The measles vaccine is very safe. And if you don't have the measles vaccine and you get measles, you do have a chance for dying. The child does, or having some long-term health complications from it. And it's definitely been disproven to be associated with autism. That there have been so many studies that have already been done in the U.S. and around the world, and there hasn't been one credible link between that vaccine set and autism.
Right.
I think the reason why people lean into that is because, unfortunately, when you get diagnosed with autism, it's about around the same time that you're taking the vaccines. So it's not necessarily, like I said before, it's an association. Oh shoot, I had the vaccine and now I got my child got diagnosed with autism, so that it must have caused the autism. That's like saying I got the vaccine, I went outside to my car, I got in my car and I got hit by a car. The vaccine caused me to get hit by the car. It's traumatic to have an autism diagnosis. But I do want to assure your listeners that there have been many, many studies that have been done around the world to look at this issue very seriously to see if there's an association or causation, and not even association has been found. There is something, probably environmental. We don't know what it is that's linked to autism and the increase in autism, but what it is still unknown, and probably is happening. Well, there's definitely some exposures that are occurring in utero that have been suggested to be part of the reason for autism, but what those exposures are it is still a big question.
Yeah, I think that might be a good area of research for some people.
Oh, and there's been a lot of research that has been focused on this.
Okay.
So it's not a new topic.
Okay.
No.
Okay.
And a lot has been learned, and there's still a lot of questions that are being targeted and trying to be identified. But there's been a lot of people who have been focusing their efforts on this area.
I think what you said about the timing, I think that makes so much sense, because the time that you're diagnosed with autism versus the time that you know that the child has to be given the measles dose is like around the same time, because of which there might be a high chance of people or children finding out that, hey, I found out this, and it might be because of the vaccine that I took.
Yes, yeah. And it's devastating. It's
It
devastating
is.
for the family. When I had my children, I decided just to be safe, I decided to space out their vaccines instead of doing them all at once. That was purely from a maternal viewpoint, not from a scientific, not from a scientist viewpoint. Looking at the literature, it was just to be on the safe side,
Right.
kind of thing.
And another important thing that people talk about is, think a lot of people think that getting a vaccine means that, hey, I have a COVID vaccine, so I'm not going to get infected by COVID or anything of that sort. Like, I have a measles vaccine, I'm not supposed to get measles. But I think I want to talk about that's not how it works. But you still can get, even though you're vaccinated for any disease, you can still get the disease. But what happens later is what we need to talk about. So do you want to take that over and talk a little about what happens, and maybe even about herd immunity, because that's very important for people to know, considering what people think about vaccinations right now.
Yeah, that is a really good point. It's not a magic shield that gets put up. What a vaccine does is it helps your own immune system fight against a particular pathogen. So, for example, for COVID, which is a virus, getting the vaccine helps protect you against getting really sick. from COVID. And also, it should clear COVID out much quicker, the virus. So if it clears the virus out quicker, then you shouldn't have, hopefully, any of the side effects, long-term side effects, because it hasn't been in the body around as long. It shouldn't infect as many cells because hopefully your immune system already generated that memory. And as soon as you get a couple of cells infected with COVID, your body is going to respond, and it's going to respond with an army. If you didn't have the vaccine, your body can't respond with an army. It responds with a very small force that takes a while for it to build up into a strong army to protect you. With the vaccine, you already have the army in place to protect you.
I think at this point, telling people about how much time it takes for body to proliferate or like make multiple copies of B and T cells to fight the immune system would be like about 14 days. That's why we say quarantine for 14 days. But in case you have a vaccine, it's probably 3 days.
It's going to be shorter. Yeah. And it also depends on how healthy you are. If your immune system isn't as robust as your neighbor's immune system, you might take longer. You might get a little bit sicker. So it all depends on the health of your immune system as well. And that gets back to your herd immunity question. There are people who have a very weak immune system. That could be because they were born with some kind of disease or some kind of genetic deficiency that caused them to have a weak immune system. That could be because they have cancer, and so they're on chemotherapeutic drugs, which all chemotherapeutic drugs will target your immune cells and kill your immune cells. So then you're more susceptible because you have a weaker immune system.
Right.
It could be a lot of different reasons why you have a weaker immune system. Maybe you're tired. You're super fatigued because you haven't gotten enough sleep. Maybe your diet. Maybe you're in a food desert and you're not eating well, and you don't have really good nutrition. So that could affect your immune system too. Maybe where you live, it's heavily polluted, and pollutants have been shown to inhibit the immune system. So there's all kinds of reasons why you might not have as functioning of an immune system. The vaccine should still help you as long as you have some functioning of the immune system, but it might not be as robust. Those who do not have a functioning immune system really do depend on everyone else getting vaccinated so that they will be protected. When we get to a point where we don't have enough people vaccinated, not only do we hurt the people that have a low functioning immune system, but we hurt everybody.
Right.
Because now we got little incubators. Everybody becomes an incubator for the pathogen to mutate. And once it starts to mutate, it becomes resistant to the vaccine. And if it becomes resistant to the vaccine, then you can end up with a pandemic. You can end up with all kinds of other problems that occur because it's also like antibiotics. If people overtake antibiotics, the bacteria will become resistant because there's this pressure. It's almost like an evolutionary pressure on the bacteria to mutate their DNA so that they can become resistant to the antibiotics, right? They've got a pressure to do that because if we overuse the antibiotic, and they will do that. But if you use the antibiotic reasonably and only take it as much as you're supposed to, which means don't just take 2 pills, I feel better, so I'm not going to take the rest, right? Take it to get rid of the bacteria, and then you're done, and we don't overprescribe it. Then it's almost like the bacteria is seeing it for the first time every time you get infected with that bacteria. So there's a lot of adaptation that occurs in the pathogens, and our body tries to adapt to those adaptations. We try to hurry it along with the vaccine. But if we don't have enough people taking the vaccine, we're allowing the pathogen to change more quickly, which then that means that we have to invest a lot more time and energy and money to develop a new vaccine that will be hopefully efficacious and work. And it just becomes a vicious cycle.
So takeaway, please get vaccinated.
I really do think that you would, I would not want measles.
Of course, yes.
I wouldn't want my children to go through that and have the potential that they could die. Even chicken pox. I had chicken pox as a child. My kids have not had chicken pox because they were vaccinated. So I'm at risk for getting shingles because when you have chicken pox, the virus doesn't actually go away; it just hides out.
Right.
And then your immune system should take care of it. But if you ever have any low points in your immune health, again, you're tired, you are stressed, you have a lot going on in your life. Stress can inhibit your immune response. Sleep deprivation can inhibit your immune response. Then you could have the chicken pox come out, and then it could be shingles.
Right.
And shingles is no fun.
Of course not.
So there's a lot going on there, and the vaccines are very helpful at trying to stop the virus or the pathogen before it becomes a problem.
I think, again, there's a little tangent to this question. First being, I think people, especially the youngest generation, they take sleep and food for granted because there's just so much stress, especially with college students, and we don't sleep well and we don't really eat very healthy stuff. And one, how do you think that really affects the immune system? Like, does it affect the proliferation? Because I'm sure it does have a mechanism deeper to it, but if you can like just explain us what happens there, one. And two, I also think the usage of ultra processed, not just food, but everything in the industry and market right now is like super processed and has like high pollutants in them. Be it your makeup, skincare, everything is like really polluted. So to what degrees would you as an immunologist and a toxicologist suggest is okay? Because I see some people using probably 16 products, 18 products only in the morning. So yeah, just your take on that.
That's loaded too. First off, I'd be careful with the term polluted because that could mean a lot of different things. All food should be tested to make sure that it doesn't contain heavy metals and other toxins in it. Most, I would hope, cosmetics are also tested too. There are some things that are more regulated than other things. So that's a consideration to think of. For example, natural, and I'm putting quotations around that, like herbal remedies and natural products and things like that. They are not as regulated as drugs are, and that's a problem because that means that there's not enough studies on them to know about toxicity and safety, and also sometimes they don't even have the ingredients in them that they're supposed to have, so they're not always proven to be what they say they are. So that's buyer beware. That is a potential scare that you don't really know that they are what they are, and they haven't undergone the rigorous testing that drugs have undergone. The other food, there are certain qualifications with food that they have to pass. So if you're going to put a dye or an ingredient in there, you have to show that it is safe before you put it in there. I know there's probably some limitations to that. There have been times when things have been contaminated inadvertently. And our Food and Drug Administration tries pretty hard to make sure those those things don't happen. But the ultra processed foods, I think it's more. In my own household, we try to stay away from highly processed, or I just heard on the radio someone called it formulated, and actually it was a former head of the FDA.
Okay.
And what he was saying is that they're formulated to have a lot of sugar, salt, and fat. And the reason why is to make them addictive. Right? Because it hits our satisfaction centers,
Yes.
right? Where this is so good. And then you want to keep eating, and then it becomes addictive.
I agree.
So if you think about it more in those terms and try to think about moderation and just eating vegetables and fruit and the food pyramid, try to be as close to the food pyramid as possible. I think that's a good approach. In terms of cosmetics, cosmetics are tested to the degree of testing that everyone does. I am not sure, because you can get cosmetics from other countries, and I'm not sure how tested they are before you're able to get them here. Like if they're on the shelves here, I would assume that there has to be some testing that goes through that is approved by the U.S.
Okay.
European testing is pretty stringent. So I think that they do look at that for cosmetics and for other products. Yeah, I'm not super well versed on the different regulations, but I know there's a lot of regulations out there that look at the chemicals that are in the products and the testing. In Europe, they really don't want animal testing to be done. So they try to look for alternative means to do the testing. We still do quite a bit of animal testing, but then if some of our companies are going to make products that are going to go to Europe, they have to conform to those testing requirements and not do as much animal testing. So you probably have seen facial products and things like that say not tested on animals, right? So they had to use something else, and often it's going to be some kind of in vitro, meaning it's some kind of cell line. It's going to be some human cells or something like that to do the testing.
Similar.
And of course, there's drawbacks, right? You may not detect everything that could possibly go wrong. Again, there's always risk. So it's kind of one of those things where you try it. If it works for you,
it works.
it's a really hard one, because how do you predict what's going to happen in 10 years? Right? So it's you got dermatologists who are supporting certain types of products, right? It might even say tested by a dermatologist. Well, I also find comfort in that, but what does that really mean? What did they actually really do? Right? So it's kind of one of those, again, buyer beware. And I fall into that stuff all the time too. Yeah.
I know. Definitely. The market has us.
Yeah, but the products that I use, I find that they don't make my skin red. So that seems okay. So I don't try a bunch of different things.
I agree. I do the same thing. I have this rule: if not more than 3 things for the skin, not more than 3 things for the hair. So that makes me reduce the amount of chemicals I'm using on an everyday basis. I mean, that's just my rule, but yeah.
Yeah, usually the less chemicals on the label, the better. But be careful about that too, because if you looked at the chemicals that are in a tomato, you'd be shocked. But they're normal. I mean, it's normal to have a ton of chemicals in a tomato, because a tomato is made up of chemicals.
The new normal.
No, but they're not. It's just part of a tomato. You know what I mean? It's not because of herbicides or pesticides. It's just that every molecule that you have in your body could be defined as a chemical, right?
In a way, yes, that makes sense.
Yeah, so it's not. I have a friend who's a toxicologist who does this. She'll put up a whole list of chemicals that look really scary, and she says, "No,
Okay.
this is a natural tomato. These are the components that you can detect in a just
Tomato.
a normal
Mm.
tomato that
Mm.
you could call it organic. I mean, it's just that's just what's in a tomato."
Wow, that's fascinating. Yeah.
So I think it's just the lack of understanding that a tomato is got chemicals in it
Mm-hmm.
because chemicals are nucleic acid is a chemical. I mean,
Yeah, it's
it's a chemical.
yeah, again, it gets down to, like you say, what's your definition of pollutants, or what's your definition of a chemical? Yeah.
Water is a chemical.
Okay. Yeah.
H2O.
Well, thank you so much for sharing so much information today, Dr. Salanter. And I'm sure my listeners would have really learned a lot, especially about things that they really should, like vaccinations and things like that. My last question today, before we leave today, is if you were to like sum up your research work and have like one major takeaway, or like one advice to the younger generations, what would it be?
That's a good question. Critical thinking. Don't believe everything you hear,
Okay.
and also don't always freak out. So it's take everything you see on social media with a pound of salt
Okay.
and look for the data. It's important for everyone to be able to analyze data, whether or not you're a scientist. A bar graph is just a bar graph. A bar graph could be of numbers that are relating to the stock market. They could be about science.
I've learned that a lot from your class, particularly.
Oh, well, good, because it's hard. Don't put faith in the influencers, and search it out and see if you can understand what you're looking at. Which I'm not saying it's going to be easy to understand the data, or it's going to be easy to understand what's out there, because it isn't easy. So we do fall back on this really easy blurb about there's all kinds of toxins in cosmetics. Well, can you trace it down a bit and see, well, what toxins are they actually talking about? And could you find out? And it's going to take work, right?
Of
Can you
course.
find out, well, why are they in there? Are they true contaminants? Or are they in there so that you don't get botulism in your cosmetic, which will then cause lockjaw and then you'll die?
I know.
So, so it's trying to track down the real data behind the statements. And I know you can't do that for everything, because you'd just go crazy if you tried to do it for everything. So I think probably the easiest thing to do is just not to believe everything, and just to kind of take a step back and say, what does EPA say, which is our Environmental Protection Agency? What does FDA say, which is our Food and Drug Administration? What does the other? I'm blanking on the other ones that are really important. How can I blank on that? But there are a lot of government websites that are very comprehensive in analyzing different chemicals, the actual risk, the numbers that are out there, and those are really good sources. I would go there. I would definitely go there first and see. Well, second, right? So if you saw something on social media, go to those sites and see, well, what are they saying about that? And then you can also reach out to professors or to scientists and ask them questions. Most scientists would be happy to try to weigh in and help you look at things and make your own decision with evidence and some context of what's going on.
Well, thank you so much for today, Dr. Salentic, and I really appreciate you making time for this. We're really coming towards the end of the episode, and is there anything else that you would want to add at this point?
Yes, CDC. I forgot that one.
Okay.
How could I forget that one? Center for Disease.
Okay.
That one is a very important source too. Yeah.
All right. Thank you so much for listening, and stay tuned for the next episode with Banter with Bacteria. Thank you so much.